the one that we derived last time, the Euler-Lagrange or the Lagrange equation of motion, and it is given by this. We have partial L, partial L. Okay, so we have this Euler-Lagrange. Uh, this Euler-Lagrange equation, q i's minus d dt of partial L with respect to q I dots, where q i's are generalized coordinates. Okay. So again, last time we did examples on free fall, free particle, also the harmonic oscillator. So another good example is we have this um, single particle in a central force field. Single particle in a central force field. So in a central force field. You have to take note, I think we discussed the central force last time, no? Gravitational field, gravitational force is also a central force, no? Central force na ako'y inline ang imong direction sa force sa katong inline line of action sa imong duha ka mass, okay? So central force field, yeah. So say for example, I have a mass with with some mass m, okay? And it is located at, if this is my xy plane, it is located at uh, a position vector r. Okay, r is not fixed. Okay, r is not fixed. So mura siya og ang imong system is na koy mass, and then reconnect nimo siya sa origin using an elastic material. Okay, so meaning kay ang iyang motion is not just a circular motion. Circular motion siya when your r is fixed. Okay, so na siya constrained siya at r, okay, at radius r. But in this case, dili siya constrained at r because r is a function of time. Okay, it is a function. It's not constant. So ang mahitabo sa imong m is the motion will be, it looks like this, no? So pwede sa mo ana, pwede sa mo ani, pwede sa mo tuyok ingani, pwede sa mo gamay imong r, ana, like that and so on, no? So dili siya circular, no? Kung circular lang siya, if your r is fixed, okay? If your r is a constant, then the motion of your mass m must be this one. So nakoy m dara, no? Fix lang imong r. So ang may tabo, ang iyang motion will be a circular motion. But in this case, your r is not fixed. Your r is not constant. Okay, your r is not constant. So your mass m is actually the motion of your mass m will look like this. Okay, so nakoy nga. So I have a single particle in a central force field. Question is, in this case, how many degrees of freedom? Nakoy duha, no? There are 2 degrees of freedom. Ano ganito? Kung fix imong r, kung constant imong r, isa lang ka degrees of freedom. And that's just equal to theta lang, no? Sakto ba? So in this case, nakoy 2 degrees of freedom. 2 degrees of freedom. Unsay meaning sa 2 degrees of freedom, napoy 2 ka coordinates. Okay, tama ba? Nakoy duha ka coordinates ani. 3 man siya, no? Minus na ako equation of constraint. The equation of constraint here is katong kaning this your mass, your single particle is located only in 2 dimensions. So 3D niya, the z coordinate must be equal to 0. So that's why I only have 2 degrees of freedom, or I only have 2 generalized coordinates. Take note, when r is fixed, then isa lang ka degree of freedom, and that the coordinate will just be your theta. Okay, so in this case, nakoy 2 degrees of freedom, nakoy r, dependent imong r, no? Mudako imong r, mugamay imong r, and so on, as a function of time, and you have also this theta, no? So nakoy duha ka generalized coordinate ani, no? Nakoy r, and then nakoy theta. Okay, take note of that. Again, when r is constant, then only the theta ang coordinate lang sa imong system. Okay? So when r is fixed, your motion will be a circular motion lang dayon. Okay? With 1 degree of freedom, and that one is just theta. Okay. So generalizing na siya nga circular motion, no? Sakto ba? So fixed, dili fixed ang imong r. So I have generalized coordinates duha, and then the constraint is just, ang constraint lang nako is only the z equal to 0. Now, so what are my generalized coordinates? I have r and theta, no? So I can say that my q1 is r and my q2 is theta. Okay. As I said last time, if I have one generalized coordinate, kung ako isa lang ka-generalized coordinate like sa free particle, sa free fall, and so on, nalampog ko isa ka Euler-Lagrange equation nga makuha, no? But in this case, since there are two coordinates, okay, naapog ko duha ka Euler-Lagrange equation nga ma-extract ani nga system, okay? Since independent man imong mga variables, imong mga coordinates, so independent po pag-solve in with respect to r and then with respect to theta. Okay? So na ko makuha nga duha ka Euler-Lagrange, no? Euler-Lagrange na I have two na ako'y partial L with respect, yes. Pilit pilit okay. Okay. Murag hinay ako, hinay mo internet kini, no? Kaya na madungog ra ko ninyo or hello? Hello?
Madawag ra sir, pero
Pilit.
mapilit-pilit siya sa sir.
Okay. Okay. Sorry kaya no, murag hinay ang internet sa kuan department. Ah. Sige lang, reklamo lang Jay kung di gid masabtan Jay, no?
Sige
Okay,
sir,
Jay.
sige sir.
Okay.
Sige sir.
So ipadayon ko, no? So I have with respect to r na coordinate, I have this minus d dt of partial L with respect to r dot, sakto, equal to 0. And then with respect to theta, I have partial L with respect to theta minus d dt of partial L with respect to theta dot. Okay, so these are the Lagrange equation of motion with respect to r and with respect to theta. Okay, so ang kulang na lang, nana ko'y, if I have the system, ang kulang na lang is, nana ko'y duha ka coordinates, r and theta, nana po ko'y Lagrange equation, corresponding Lagrange equation sa duha. Ang kulang na lang is to find the Lagrangian. Okay? So, ang kulang na lang is find the Lagrangian L. So, in this case, in this system, what will be my Lagrangian? Okay? So, L here, solve na tong L, no? L is just, take note, L is just T minus V. Okay? I have, in Cartesian coordinates, we have this. The kinetic energy is just equal to 1/2 m x dot square plus 1/2 m y dot square. Sakto ba? Because this is in plane, in an xy plane, okay? This is in an xy plane. I have the position of this one is y, while the horizontal position is x. Sakto? So therefore, na ako'y duha kinetic energy. Kinetic energy along x and or plus kinetic energy along y. So I have two kinetic energies, horizontal kinetic energies of your mass and vertical kinetic energies of your of our particle with mass m. Okay. But take note, ang atong generalized coordinate kay gamit is not in Cartesian coordinate but in plane polar coordinates with respect to r and with respect to theta. But I know this transformation. If I recall, there is this coordinate transformation, tama? Kung kadumdum mo sa una sa theoretical mechanics 1, there is this coordinate transformation nga if I have this, okay, na ko nga ni, this is r, this is theta, and then this is y, and then this is x, na ay relationship si r theta og sa imong y og x. Okay? So we have this transformation such that x is equal to r cosine of theta while y is equal to r sine of theta. Sakto? So na ko'y coordinate transformation nga ni from Cartesian to plane polar or from plane polar to Cartesian. Okay? So I have this coordinate transformation, r cosine of theta and r sine of theta. So we have this. Take note here, r is not fixed. So if you take the derivative, if you take x dot, okay, kung kuhaan na kong derivative si x with respect to time, kung saan ako makuha, there are two terms, right? Using product rule, I have r dot because r is not fixed. Unlike sa katong atong example last time, circular motion lang, i-consider na to si r as a constant um, number. So, if you derive that one, derivative of a constant is just zero. So, that's why isa lang ka-term ako makuha sa akong x dot. But in this case, r is not fixed. So, we have, using product rule, na ako'y r cosine of theta minus r sine of theta. Sakto ba? Because first, derive the r, maintain the cosine, plus maintain the r, derivative of cosine theta is negative sine theta. So that's why na ako'y minus r sine of theta there. And we have also y dot, na ako'y r dot sine of theta uh, plus r, derivative of sine is cosine of theta. Okay. So there is this relationship between x dot and y dot. If I plug this into our kinetic energy, plug in ako na sa kinetic energy, no? So na ako'y 1/2 m x dot square, which is just this. Walang i-plug in, no? Cosine theta minus r sine of theta quantity square minus ba? Plus there, sorry. Plus 1/2 m y dot square is r dot sine of theta plus r cosine of theta. Medyo taas siya, no? Pero later on, na yung mag-cancel out if you simplify this one. Na yung mag-cancel out alin? Uh, kaning somewhat na yung minus r and plus r dira. So, try na to, no? Uh, simplifying this further, you will get sa ko makuha. Oh, sorry. Napakoy theta dot, sorry. Because you derive the theta here. Okay, not just the sine theta. So, nakoy kulang, no? Nakoy kulang diri, no? Oops. Napakoy kulang diri. Because derivative of cosine theta is negative sine theta, theta dot. Sakto ba? So, napakoy kulang diri nga theta dot. Okay, this is theta dot. Uh, sine of theta. And then diri is theta dot cosine of theta. Okay, tama ba? Derivative of time derivative of theta is we have of cosine theta, sorry. Of cosine theta is negative sine theta times theta dot. Okay, so that's why nakoy theta dot dira. So napay kulang diri gamay, no? Napakoy diri, then napakoy sa dira. Okay? So uh, minus this one. R theta dot, tapos diri is plus R theta dot. Okay, so if I simplify this, you will get T equal to, I factor out the 1/2 m. Okay, factor out na ako 1/2 m. Using FOIL method, this is equal to r dot square cosine square theta. Sakto? R dot square cosine square theta minus 2r minus 2r dot r theta dot sine of theta. Sakto? So, minus 2 r dot theta dot r cosine of sine. Okay, sine. Okay. Cosine dira. Okay. Plus r square theta dot square theta dot square sine square of theta plus the other one we have r dot square sine theta. We have r dot square sine theta square. Tapos ang isa is plus 2rr plus 2r dot r theta dot sine theta cosine of theta plus the other one is cosine square r square theta dot square cosine square of theta. And as I said, do they mag-cancel out? This one and then this one. Okay? And then if I combine the first term and the 1, 2, 3, 4, fourth term, na ko makuha ang ingani, no? T is just equal to 1 half M na ko R dot square cosine square theta plus sine square theta. Tapos ang isa is na ko R square theta dot square sine square theta plus cosine square theta. Okay? Which is just equal to, this one is just equal to 1. This one is equal to 1. This one is, mag-cancel out na siya. Okay? So, I have that. So, therefore, from Cartesian coordinates to plane polar, makuha na ko ang kinetic energy nga equal to this one. 1 half M na ko R dot square plus uh, R square theta dot square. If you do this, I have, yeah, na ko two terms, okay? As you can see, I have two terms here. Okay? First term is for the translational motion of your single particle. The second term will be the circular motion of your of your single particle. So first term is the translational kinetic energy, while the second term is for the rotational kinetic energy. Take note, if you remember, uh, this r theta dot, pagkadumdum mo aning r theta dot, this is just, so ito, r omega, sakto? R omega, and omega is the angular velocity of the particle. Okay? Pagdumduman no? So this the second term kani r theta dot quantity square. Okay? Quantity square is actually a term for the rotational kinetic energy part sa imong system. First term is in translational kinetic, while the second term would be the rotational kinetic energy. So always to makita ani no, take note of this. Basta gali mugtuyok imuhang basta gali mutuyok ang imuhang particle, there is a circular motion. Kung as you can see sa atong example, ang imong M is there will be a rotation. So na siya rotational, na siya kinetic, and na po siya rotational. Na siya translational kaning painganing nga motion, because R is not constant, so na siya painganing nga motion. Okay, translational at the same time na po siya rotational nga motion. So if you combine that, the total kinetic energy would be the translational kinetic energy plus the rotational kinetic energy. So I have this form for our kinetic energy. Okay? So, i-familiarize nato ni no, na always makita kitag R theta dot quantity square sa ato ang kinetic energy if our uh, particle is moving in a circular, somewhat in a rotational motion. Okay? In a rotational motion. If, as you can see, if R is fixed, what will happen? There will be no linear kinetic energy, no? Kung R is fixed, the first term becomes zero. So therefore, only, ang mag-survive lang is only the rotational kinetic energy. Okay? Kung circular motion lang, mawala akong first term because R dot becomes zero when R is constant. Okay, when R is constant, R dot is zero. Ang mabilin is the second term of your kinetic energy, and that would be the we call that one as rotational kinetic energy of your system. So wala na siya translational, no? Kaya di man mo inat imong mass, no? Wala may fixed man imong R, okay? But again, the general, if I have, say for example, your mass is in 3 dimension, automatic na gina siya tulo ka kinetic energy. Kinetic energy along X, kinetic energy along Y, and kinetic energy along Z. Okay? So in plane polar, I have two kinetic energies. Kinetic energy on R, if assuming that R is not constant, and kinetic energy on the rotational part sa imong system. So we have that. And V is not given here. V is just VR. Okay? Central potential. Because we know that in the given problem, your single particle is inside a central force field. And when you say central force field, take note, central force field is, if you remember, your F is just a function of R. Okay? Your f is just a function of r. And from that, you can actually get uh, the potential, right? Kabalutan mo ko ang potential, which is just equal to this, right? The gradient of v with respect to r. Sakto? If central force ang ako ang field, I can conservative akong force, I can solve for the potential energy. Okay? I can solve for the potential energy, which is just equal to this expression here. Okay? So, ingani siya o formula ko. Okay? So, if I have central force, any central force, no, makakuha ako og potential. So, let's just generalize our expression of our potential. Okay? Generalize, not generalize, general potential energy. Okay? Which is just a function of R only, no? Nganong function of R lang siya because take note our force is a central force, okay? Our force is a central force. So only V is just only a function of R, not a function of theta, but only a function of R. Okay? So I have V is just any V as long as depende sa imong F, no? Depende sa atong F. So therefore, my Lagrangian is just equal to thus dl is equal to t minus v, which is just equal to 1 half times m r dot square plus isa to r square theta dot, no, muna sa rotational nga part, minus v as a function of r. Okay. Now take note f here, the potential can be solved if na ako'y specific function sa akong central force. Okay, so we could yeah, could obtain so we have that okay. So the equation of motions, so nana ko L, no? Nana ko L. Makuha na ko ang equation of motion na daya, no? Makuha na nako ang equation of motion. With respect to R, the equation of motion becomes this. Equation of motion, we have, in terms of R, I have L R minus d dt of partial L R dot. Pila ni siya? Equal to 0. So, partial L with respect to R, pila ni? Partial L with respect to R is what? Partial L with respect to R. Akong L kay kanino? 1 half M R dot square plus R square theta dot square minus VR. Pilay ako ang partial with respect to R, ani? The first term becomes 0 because 1 half M R dot square is just constant with respect to R, so that's 0. So, naakoy kanino? Naakoy 2R, pero naakoy 1 half sa gawas, so I have M R theta dot square. Sakto? My the derivative sa akong first term with respect to R, partial derivative with respect to R is we have MR theta dot square. Kanila ang mabilin, no? Kanila ang mabilin. Okay? Napaki 1 half M sa gawas. And then, of course, V is just a function of R, so na siya derivative. So this is partial of VR with respect to R. But V is just a function of R, so you can actually transform the partial into total derivative. Okay? You can just transform the partial derivative with respect to total derivative. And I know this one, no? Kabalo kung kani siya is just equal to f of r. Sakto? Tama ba? The the negative, ano? Dapat na negative, no? Dapat na negative. Yeah. The negative, sorry. Akong turuan, no? Kani, ano ito? Tama, no? The f of r is negative dv over dr. Okay, so nakoy negative dira. So therefore, kani tanan apil ang negative na sign. So, isang tanan ko. Apilo na ako ng negative na sign. Okay, so apil isa. Okay? So again, we can the first term is just equal to mr theta dot square plus na, no, plus f FR. Okay, so this is my partial L with respect to R. How about the other one? The d dt partial L with respect to R. Okay. I know that partial L with respect to R is just katulang first term, the translational kinetic energy. Kanilang, no? Kanilang ang mag-survive. Okay, so I think that's mr dot. Okay, that's mr dot only. And then doing the total derivative, d dt of mr dot, that's equal to mr double dot. So therefore, the equation of motion is just this. Equation of motion is just equal to, so ito, m um, r theta dot square plus fr minus mr double dot equal to 0. So therefore, na ko mr double dot equal to mr theta dot square plus f of r. Aha. Aha. Okay. Did you remember this equation? Na dumduman pa ninyo ng equation? Sa chapter, dumduman eh. Ito. Chapter 6, katong central force. Okay? Kadumduman ng equation, no? Central force nga topic. Check na to ha, kung na ba niya. Sa central force nga topic, natin nakita ang equation nga to, no? Central force. Oops. Central force. Force dito. Gani, no? Gani. Dito. May tanong to kung parehas ba siya nga equation, no? Oops. Lagay na ba to? Ano to dito? Kadumdum mo no? Na mr square root theta dot. This L is not the Lagrangian but the angular momentum. Okay? Angular momentum. Di pa tumaw. Ara, no? Bali. SR. Di ni siya mo. This is for the rotational niya nga part. Okay? Rotational niya nga part. But ang iyahang nara, no? Kanisa. This one. Six 6.5.2a. As you can see, this is the equation of motion of a particle in a central force field. Okay? In a central force field. So, para sa naman siya, no? If you transpose the minus mr theta dot square sa pikas, makakuha ka og nga equation. Okay? So that's the equation of motion of a particle. Kung di ka gusto ani, no, taas-taas mo gulo ng derivation ani kanisa dire. Oh, wala niya gi-derive. Wala niya gi-derive. Anyways. Isa to. Okay. So yeah, that's it. No, for a single particle in a central force field, the equation of motion is equal to this one. Ang nakakuan lang sa pikas, kani siya, i-appeal mo na isa. I-appeal niya ang with respect to theta. So, isa pa rin siya ka Lagrangian, no? This is with respect to theta pa, no? Tama ba? This is with respect, not theta but r, no? Napatay isa ka book, equation of motion nga makuha. With respect to theta. That is with respect to r, kani siya is duha man ka Lagrangian ako makuha, duha ka Lagrange equation ako makuha. This is with respect to theta. And I know that this is equal to this, d dt partial L partial of theta dot equal to 0. Okay? So if I derive the Lagrangian with respect to theta, sa ako makuha. With respect to theta, that's equal to 0. Sakto ba? 0 ba? Okay, itong Lagrangian ako. Kanino? My Lagrangian is this. If I derive this one with respect to theta, wala mo ko'y theta nga makita, no? So therefore, this one is 0. Okay? For partial L with respect to theta dot, sa ako makuha. With respect to theta dot, so kanya akong derive, no? Kanya akong derive. So that's equal to 2, mawala ang 1/2. So nakoy mr squared theta dot lang. Okay. mr squared theta dot. mr squared theta dot. If you do d dt, if I do d dt of mr squared theta dot, okay, that would be equal to what? Nakoy duha ka buok naman kuha, right? I have, this is with respect to time, so nakoy using product rule, this is equal to 2 mr, I will derive first the r, mr r dot theta dot plus with respect to theta, so nakoy mr square theta double dot. Sakto ba? I derive it using product rule, so nag-derive ko og r una, so nakoy 2r, sakto, 2mr r dot theta dot, yeah, that's correct, plus mr square theta double dot. Okay, so therefore I have the equation of motion with respect to theta is we have this d dt of mr square theta dot, nawala ang isa, so theta dot lang, oh yeah, theta dot lang equal to 0. And I think kani siya, which is just equal to this, right, which is just equal to that one, kani siya, as you can see, kanus zero ang derivative, it is when your mr square theta dot from this, wala na ko ng zero, no? Wala na siya, wala na siya. Okay, so this is the equation of motion for a with respect to theta, okay? And ang meaning anis is what? Kano sa zero ang derivative, it is when your mr square theta dot is a constant. And I think na-explain na po na ako ni last time. I think nasa dire, no? Kani siya, no? As you can see here, the r square theta dot, okay? The r square theta dot is equal to 0. Okay, so that's the equation of motion in terms with respect to theta, no? R square theta dot is equal to 0 because you can actually factor out the m here, right? You can actually factor out the m and then divide both sides by m. You will get r square theta dot the dt of r square theta dot is equal to 0. So somewhat muna ako makuha nga differential equation of motion. And it simply means that mr square theta dot is constant and this, kung kadumdum mo, kani is gihimo or gilet na ko ni siya as the angular, the L, tama? The angular momentum per mass. Sakto ba? R square theta dot is L and that's the angular momentum per unit mass. Okay? So, makuha gyapon na ko na siya nga mga terms using Lagrangian mechanics. Okay? So, that L, take note, is the angular momentum per unit mass. Di na ko isulat ang L nga dako because basi ma-confuse mo na L here is the Lagrangian, not the angular momentum. Okay? So, L must be a constant. Then, once makuha na ko nga si angular momentum is constant, then I can solve or I can derive the Kepler's law of motion. Tama ba? Nakoy equal areas, nakoy law of ellipse from this definition, nakoy law of ellipse. Under a central force field, I can solve, I can prove that Kepler's law of planetary motion. Okay, so that's it. Yeah, that's for the particle. That's for the particle in the central force field. So as you notice, tanan actually system, say sa central force siya nga topic, masolve gyapon nato siya using the Lagrangian mechanics. Okay? Using the Lagrangian mechanics. Question?
Wala na, sir.
Okay. Ma putol-putol gyapon ang tingog, Jay.
Wala, sir. Okay ra, sir.
Okay na. Yeah. Okay, so yeah, that's for the single particle in a force field. Now, let's go to, I think, naani siya sa inyong midterm exam ba to? Yeah, naani sa inyong midterm exam, no? We have this, alas na lang, no? Another example, we have this Atwood machine. Naani sa to ang basic, no? Basic na problem sa physics is this Atwood machine. Okay? And naani siya sa inyong midterm exam actually. Pero, dili siya parehas gyud nga system because in this case in the midterm exam nga case wala na ko gi-appeal ang pulley, tama ba? Wala na ko gi-appeal ang pulley. We neglect the mass of the pulley, frictionless akong pulley and so on. So that's why nala ko'y duha ka object na nag-interact sa imong system. But in this case for Atwood machine nga kani we will include the pulley here. Okay, so include nato ang pulley. So for Atwood machine, I have a pulley, I have a mass, okay, mass 1, and then I have mass 2 here, okay, and then the radius of the pulley is some radius A, for example. So in this case, unlike sa inyong midterm exam, uh, si pulley kay wala na ko sa gi-appeal sa akong system, okay? Sa midterm exam nyo, muna sayon-sayon to siya, no? Sa midterm exam, wala na ko gi-appeal. I neglect the mass of the pulley, frictionless pagod ang pulley, and so on, okay? But in this case, we generalize the Atwood machine. We will include, of course, na pulley ang Atwood machine, no? Ako'y pulley and then duha ka mass. So we will now include the pulley in our system. Okay. So I have the length of the string. So now ang length sa string is L as length L. Di lang ako tiwaso, no? Tama na tag 4, okay? The string has length L. We also have this I, since there is this rotational motion of your pulley. Again, gi-appeal na ko ang pulley sa akong system. There will be this so-called I, and this I called the moment of inertia. Okay? The rotational analog for mass is I, and I is called the moment of inertia. The pulley rotates appropriately. Appropriately. And there are how many constraints here? I have 3 bodies, right? Ako'y tulo ka bodies, the pulley, the mass 1, and the mass 2. But I have um, 5 holonomics, 5 holonomics constraints, okay? Na ako'y 5 holonomic constraints. Na ako'y holonomic constraints, okay? Na ako'y upat ka, gani? Y equal to Z equal to 0. Upat kay nga ni. Ang upat kay na ako'y isa ka duha sa M1 and then duha pud sa M2. And isa sa ako ang pulley, no? Upat ka Y equal 0, duha ka Y equal 0, duha ka Z equal 0 because na ako'y M1 ug M2, tama ba? And na ako'y constraint for the pulley. And the constraint for the pulley is we have this, x1 plus pi a plus x2 minus L equal to 0. I will let this one as x1, okay? I will let this one as x1. And if this is x1 and the length of the string is L, so therefore the kaning ang length ani is equal to L minus x, okay, minus pi a. Asa gikan ang pi a? Pi a is kaning semicircle nga circumference, okay? Ang length ani nga circumference kaning nabilin kani siya is actually a equal to pi times a. Okay? So I have take note the length of the string is L. Giminus na kog x1, okay? Giminus na kog x1. This is x lang, so x which is equal to x, okay? So say x1 is equal to x. So the length of the string is L, minus na kung pi a katong wala nimo gi-appeal diri, no? Kaning semicircle nga length, okay? And also the x. So that's why the x2 is equal to this one here. Okay? So x2 is equal. So Yeah, I have 5 holonomics constraints. Y equals 0, duha ka buok. Z equals 0, duha ka buok. And then, constraints ako ang bully, which is equal to this one. X1 plus pi a plus x2 minus L equal to 0. So, I have this 5 holonomic constraints. I have originally 9 degrees of freedom. Okay, tama ba? 9 degrees of freedom. So, therefore, I have uh, dapat isa lang. Isa lang. 6, 6. Ah, yeah. I only have 1 degrees of freedom in this case. Okay, for Atom machine. Okay, so I will continue this one. I will continue the what will be the equation of motion of a simple Atwood machine. And then after that, so unahan ako ni, we will continue this one. After that, we will solve the double Atwood machine next meeting. Okay, double Atwood machine next meeting. And if napatay time, we have a particle sliding on a movable inclined plane. Okay, movable inclined plane. Okay, do you have any questions?
None, sir.
Okay, so let's have a picture, a screenshot for your attendance. Please turn on your camera. Uy, complete on tatagayan, ano? 2, 4. Juben, nakauli na ka, Juben?
Nako MC sir, balay-balay.
Oh, okay. Niapil ka o kuan, rally?
Wala sir.
Ah, wala. Sige.
Kakamping na, sir.
Ay, kakamping din siya. Ah, oo, tama, no? Kadamdam ko. Tama. Wala, di lang sa mag-away, anak, ha, kay bahala na lang, politika dira. Sige. Sige, paki-on ko sa imong camera, Twiko. Ah, Juliana, no? Juliana, gusto ko mo tanaw sa naong ni Juliana. Juliana? Hello? Hello, Juliana?
Sir,
Ah, kana. Okay, sige. 1, 2, 3. Okay. Uy, 2 joints ko na, Jay. Bad mo na. Bad na, Jay.
isko ko, sir.
Ah, isko ka.
Sakspan.
Sige, bahala na mo sa inyong butara, no? Watay ko na na. Di lang ta mag-away, dahil na na. Para. Wala. Okay, goodbye. See you next meeting this Monday.
Yes sir.
Bye-bye.
Thank you.
Bye sir.
Bye-bye.
Thank you sir.
Thank you, Juben. You were just a dream that I once knew. Never thought I would be right for you.